Okay, last video. What about our weather actually affects air pollution? So what I actually have here, this is a picture that Dr. Clements has in the past to show how bad air can get. This is actually photochemical smog in San Jose. That's actually San Jose that's actually being shown there. And that brown layer that you're kind of seeing in the background, that is photochemical smog. So basically all that nitrogen dioxide, all that nitric oxide that was shot out of tailpipes reacted with sunlight to produce ozone. That happens every day. But some days that ozone ends up sitting down near the surface of the earth. It ends up hanging out down near the ground to where we're all breathing it in. Many other days it floats away and mixes out and there's no problem. So what is it about our weather that differentiates days where it mixes out from days where it just stays and builds and builds and builds? Well, wind plays a role. And the reason why wind plays a role is that wind actually causes mixing. Wind actually brings in clean air to mix in with polluted air. And that dilutes the pollution. An old phrase from the 1950s was, dilution is the solution to pollution. Dilution is the solution to pollution. And basically, what this actually caused was, this actually caused a lot of factories and industries to build really tall smokestacks. That's why smokestacks are really tall, because the higher up the smokestack is, the less friction there is. The less friction there is, the more wind there is. So this would actually allow smoke that was rising out to then shoot out. As it shoots out, it spreads out. As it spreads out, it dilutes. The negative thing, so this actually is really good for areas that are right near the factory, because all the pollution is now being blown away, it's being diluted out. However, if you're downwind from this, all of that pollution is now coming towards you. And in fact, there are many days where our air quality suffers because of something happening 200 miles away. Not necessarily industrial either. It could be a forest fire, or it could be a wildfire, something like the Camp Fire of 2018 that occurred near Chico actually gave us here in the Bay Area such bad air quality that we actually had to shut down our school for a week. Stability. So all of that parcel of air stuff that you remember from like 3 months ago, well, that actually plays a huge role as well. The reason why that plays a really huge role is if the air near the ground is stable, nothing can really rise off the ground. And anything that does rise off the ground quickly sinks back down. So any pollution ends up rising and then just sinking right back down to the ground, creating a pretty thick layer, and you can actually see one here in this picture, a pretty thick layer of smog. Well, what factories did was they made their smokestacks even taller. The reason why, if they're tall enough to bypass that surface stable layer, oftentimes a surface inversion, if the smokestack ends up being above that, then all of that smoke ends up floating away into the free atmosphere, and the air quality near the ground ends up not being so bad. This can be really problematic at night, though. If you remember, at night, the air near the ground ends up being a lot cooler than the air higher up. And so at night, any factories that don't have really, really tall smokestacks, but are still shooting out smoke, still emitting smoke, can actually shoot that smoke up But then because the air right near the ground is stable, all that smoke, rather than it continuing to go up and leave the atmosphere, it ends up just hanging out near the ground. And hence, you and I are breathing in it. You and I are breathing it. This is even worse if you live in a valley area. One of the reasons why the Central Valley, if you go back to that one image of the unhealthy air quality days, you notice that the Central Valley of California, even though it's not necessarily very urbanized, still has really bad air quality. The reason why is because topography can also play a really big role. Going back to, this was chapter 3 in our textbook, going back to the role of topography on air, at night, cold air sinks. Cold air sinks down to the ground. If that ground happens to be a sloped mountainside, the cold air actually rolls down the ground and settles in the valley below. And what that can actually do is all that cold air settles in the ground below. That creates an inversion. That inversion keeps anything that's down near the ground, down near the ground, down near the surface of the earth. Any pollutants end up being stuck down near the surface of the earth. This can actually create really, really bad issues for valley areas. Silicon Valley is kind of lucky because we have the San Francisco Bay not too far away. That helps us a little bit. But our air quality can still be worse than much of the rest of the Bay Area because we're in a valley. The Central Valley gets really bad air quality because of this feature. Air coming down from the Sierra Nevada and air coming down from the coastal ranges settles down on the valley floor. Any pollution from all the trucks that are going down I-5 gets stuck there. It's a mess. It's a big mess. An even worse place, Los Angeles. I mentioned earlier, why is Los Angeles so polluted? Well, the reason why Los Angeles is so polluted is twofold. One, you've got those mountains that actually basically turn the Los Angeles area into a bowl. So you've got these mountains that are wrapped around Los Angeles. Two, Los Angeles can actually get pretty warm during the daytime. It's at a pretty low latitude, gets pretty warm during the daytime. Three, Los Angeles is right next to the ocean. Everyday sea breezes come in, and that creates inversions. So what you end up having is you end up having a lot of photochemical smog because there's a lot of sunlight. Inversions being caused by sea breezes coming in, and you end up having topography surrounding LA, basically trapping all of that pollution in LA. Combine that with the fact that LA is an extremely popular or populated area. Lots and lots of cars on the road. It's a very car-centric area. There's a whole song called Nobody Walks in LA because everybody's driving. So lots and lots of cars, therefore lots and lots of emissions. Lots and lots of photochemical smog. So lots of sunlight, topography that basically turns it into a bowl, frequent inversions, partially because of the sea breeze, and then lots of people driving around. And so the joke in LA is that you chew your air because the air quality is so bad there. The air quality is so bad there. So it can be really, really severe. So just to summarize everything that we covered in this particular part of this module, primary and secondary pollutants. Primary pollutants are pollutants that are put in the atmosphere by direct activity, pumping nitric oxide and nitrogen dioxide into the atmosphere. Secondary pollutants are pollutants that form in the atmosphere via chemical processes. Photochemical smog is a very common form of a secondary pollutant. And then some of the factors that affect air pollution: wind, stability, topography, the geography of a region, the different factors that actually affect how much people are emitting. And so some places like Los Angeles in particular can be very, very, very polluted as a result of that. And that's it for this particular module. Thank you for watching. Please don't hesitate to let me know if you have any questions. Thank you for watching.